G'day team, welcome back to another video on the applications of calculus, and today we're going to be looking at stationary points. Now in the last video we looked at whether functions were increasing or decreasing using our sign diagrams, but today we're going to take it a little step further and analyze what all these pluses and minuses actually mean. Now a stationary point is a point where f dash of x equals 0, so that means my tangent is horizontal. Now, the cool thing about our sign diagrams is when we're solving for our f dash of x equals 0, that actually solves for maximums, minimums, or stationary points of inflection on our original function. Now, if I had a plus here and a minus here for my f dash of x sign diagram, this is an increasing function, so I'll put a little increasing line there. This bit here is decreasing, so I'll put a decreasing line here. Now that kind of looks like it reaches the peak or a maximum. So that's a way we can determine a maximum. Conversely, if I have a negative and then a positive, I've got a decreasing, increasing. That looks like it comes down to like a little valley or a minimum, okay? But then if I have a plus or a minus and a minus, they're my stationary points of inflection. Now they kind of look like this, and I'll try and draw one nicely. That little point in there. It's not a very good graph, but we know that it's that little point in there, okay? So let's do a quick example. So we're going to find and classify all stationary points of y equals x plus 1 over e to the power x. Now, a bit like the last video, I do have a quotient rule that I can use to deal with this guy. So let's do that now. So I've got u equals x plus 1, u dash equals 1. Then I've got v, which equals e to the x. And we love e to the x because its derivative is just e to the x. So now I need to find my derivative. So it's essentially the same problems as we were doing last time. All right, so find the derivative, and then we're going to find when that equals 0. So my derivative, u dash v, e to the x. Then I've got minus e to the x times x plus 1 all over e to the 2x. Now, what I want to do is try and simplify this as much as possible. Remember, on a sign diagram, the top will give me 0, the bottom will give me an asymptote, okay? Well, the top will give me an x-intercept, should I say. So let's solve the top equals 0. So e to the x I see as a common factor. So then I can take that out there, which equals 0. So e to the x can never equal 0. Okay, so we ignore that using our null factor law. On the inside, I got 1 minus 1, which is 0. So negative x equals 0. So x is 0. Now that's an x-intercept. Now to find an asymptote, e to the power of 2x will never equal 0. All right, so there is no asymptote there, so I can just ignore that side of it. So let's now draw my sign diagram, and it's a nice easy one because I've just got one value for x there. This is f dash of x, and I've got my x-axis there. Now let's choose a number less than 0 and a number greater than 0. So negative 1 and 1 are fantastic options. Now, if I'm putting that into this function here, negative 1, I'll do it along with you, so nice and hopefully quickly. I've got e to the power of negative 1 minus e to the negative 1 times 0. All right, so that second term up the top there cancels out over e to the power of negative 2, which is a positive 2.718. So that is a positive number there. Now, if I substitute in 1, this here becomes 2, e to the x minus 2, e to the x is negative, over e to the power of 2x, that is a negative number, so I get a minus there. Now this is where we put in those little lines, our little increasing one there and our little decreasing one there. And we can see we get a maximum at x equals 0. But to classify our stationary point, we need the y value as well. So y equals 0 plus 1 over e to the 0, substituting that x value into my original function. Now that is just 1, therefore my maximum is at the coordinate 0, 1. All right. Now, it's really important that you are writing down the coordinate of the maximum and the minimum. So when we then start graphing these, you can put all the relevant information on your graph. Hopefully that helps, and I'll see you in the next video.